Yeah, thank you, Shama. So, so good evening, everyone. I am Sandeep Rajakrishnan. I'm currently in my third year of BTech CSE, and this is the first time I'm co-hosting a workshop. So hopefully you guys will enjoy and gain something informative out of it and not fall asleep. Right. So, and since we are going to dive a bit technical, so I request all the beginners, I see that a lot of first years have joined. So I request all the beginners to not get overwhelmed by the architecture. So I will actually walk you through and we will build the architecture step by step. We will add the components step by step. And you feel free to interrupt me or us and ask your questions, right? I can see that we also have some cloud practitioners and associates in the audience. So they will be happy and willing to answer your questions. So yeah, let's get started and let me just share my slides. 1 minute, hold on. Yeah, are the slides visible? Can someone confirm?
Yes.
Yeah, it's visible.
Yes.
Yes.
Yeah, so far you learned about AWS regions, availability zones, and now let's go ahead and actually build an application, right? So let's say we want to build a simple social media application, maybe a mini version of Facebook, or it's similar to Instagram. And then we will see how to design the same architecture using AWS Cloud Services. So let's name our application as fb.com. Right. And so first thing, if you want to deploy your application in the on-premise data centers, you would have seen the image which Shama showed you. So if you want to deploy it there, the first thing that you will require is a private network so that everything is secure. Right. So next thing that you would want is a web server and the IP address. So to start with, suppose we are building a startup, right? So we will actually write a small code in PHP and we'll run some kind of application server or a web server, and it will work well for at least 100 users. And our users will be able to access our website or the web application using a public IP address. So the IP address would be like 192.168.4.5, something like that, right? So next thing that we add is the application server and the databases. So you can see that what is the use of this is that all the front end, all the UI components, all the HTML and CSS would be handled by the web servers, whereas all the business logic and the backend work connecting to database, all that would be handled by the application server. So the load would be distributed evenly, right? So and further, if you want to go ahead and extend your, since it is a social media application, we will have a lot of data, right? So if you want to extend, we'll be required to extend our architecture with databases like MySQL, or you can even go ahead and add a NoSQL database, which we'll be adding later in these slides. So this that you see on your screen is what is actually called a 3-tier architecture. So this is actually a good architecture and it works well, considering that our application is really good and it's doing really good, and our website is gaining more traction. Your friends start liking the website and they invite more people. So this is where a problem arises, that when a lot of people are hitting the web servers, that means that when we have a lot of traffic coming into the web servers, it will cause a bottleneck situation. What do I mean by that? So let's say a lot of people are coming in at the same time, right? A lot of people are coming into our website at the same time. So the web server or the application server would not be able to handle all of them at the same point of time. Okay, it wouldn't be able to handle the requests of so many people coming. So we need a solution for that. And that's where we introduce something called, that's where we introduce the concept of scaling, and something that does the scaling is the load balancer. Right. So so we typically scale. And now what is scaling, right? Scaling can be done in 2 types. It is vertical scaling, which means that you increase the capacity of these machines that you see on your screen. Maybe you increase the RAM, you increase the storage size, or you can actually go for horizontal scaling, which means that you bring in more machines. Okay. So so let me give an analogy for that. So let's say you are the only person in your house and you are using a washing machine, right? So for the first few days, you load it with clothes and everything is working fine. But what happens over the days is that you have your relatives and everyone coming over. And then what happens is that you have a lot of clothes to wash. So in that case, your one machine is not able to handle that many clothes. So you have two options. Either you can increase the size of that machine, washing machine, that is called vertical scaling, or you can buy more machines and distribute that clothes among those machines, right? And that is called horizontal scaling. So typically in a three-tier architecture, this is the three-tier architecture that you see on your screen. And typically in this three-tier architecture, we will scale horizontally. That means that we will buy in more web servers and application servers. Since we have multiple computers or servers, we will also have multiple IP addresses, right? So now is the time where we need someone to distribute that load. Okay, we understood that the load has to be distributed, but we need some entity or some intelligent entity which can distribute that load, right? So, and since we'll have multiple IP addresses, so we need that entity who can really distribute the load to these web servers, and that's where we bring in the load balancer service that you see on your screen. So whenever a user hits the request to the load balancer, so whenever a user comes into our website, the load balancer will evenly distribute these users to the backend servers. Right. So hope you understand that concept. So moving on, so we have next what we add is the DNS server, the NoSQL database, and caching. Right. So what is the DNS service? So as I said in the previous slide, you can see that our users are coming into our website using an IP address. So typically, whenever we type into the Chrome, we type in google.com or we type in facebook.com, right? We don't type in 192.168.10.5, something like, we don't type that. So we as humans cannot remember all those numbers. So we need some name or some alphabets to actually map it. So that's where the DNS service comes in. Okay, so what the DNS service does is that it maps that particular IP address through which your users were coming into the website. It will go ahead and map that to a name that we specify. So since here we are specifying fb.com, it will map the IP address to that particular domain name. Right. So so far so good. So let's say now that you have the domain name, so people don't need to remember all the IP addresses, and you see that more and more people are coming into your social media application. You see that your friends are growing, the number of connections are growing. So they're putting out more and more posts and videos, and that's where the relational database cannot really serve that kind of a storage. So you cannot do that. So the relational databases are not that good when it comes to scaling. NoSQL database have a greater advantage when it comes to scaling, right? So that's where we bring in the NoSQL database. And what is the DB cache? So this DB cache is the same thing as the load balancer that I explained. So similarly, when a lot of users are accessing all these posts and videos, so what the app server will do, it will go to the database and tell the database that, okay, give me this video or give me this post. It will keep on asking, right? That time the relational database might not be able to serve it all at once. So what we need is an intermediate entity called a DB cache. So what the DB cache does is that the frequently asked data. So let's say if a post goes viral, that post is frequently accessed by a lot of users in throughout a region. So what the app server will do, it will actually cache those data into the DB cache, and that can be served with low latency. So the responses will be quicker, the posts and videos will load quickly, right? So next thing that we would go ahead and add is the external storage and a content filter. So so now we know that now in the screen, actually you can see that your virtual machines, which are the web servers and application server, they have something called the disk. They have the disk attached to them, right? But the disadvantage of that disk is that they are limited storage and you cannot store vast amount of data. But in an application like Facebook, you will actually upload millions of pictures and videos daily, right? So now this is where those virtual machines and that disk, it is not capable of handling that much amount of data. It's not capable of storing that much amount of data. So for this, you need some kind of an unlimited kind of an external storage. It's okay, you can say it like Google Drive, but it's not exactly Google Drive. So now this is where we need some kind of an external storage. So that's why we have brought in this component. And whenever you post a video or a image on Instagram or Facebook, we can see that if there is something objectionable about that content, let's say if there is something that is sensitive about that content, we see that Instagram automatically flags it. Instagram or Facebook automatically flags it and says that, no, you cannot update, you cannot post this video or image, right? So that is what the content filter does. So the content filter actually, before that the video or the image is uploaded and stored in the external storage, it will filter out the contents which are objectionable and give feedback to the user that, sorry, you cannot post this, right? So that is where the content filter falls. And now going ahead, we have something called clickstream analysis. So you might have seen, okay, how does Facebook run? How does Facebook get revenue? Mostly it comes from their ads, right? So you know that Facebook throws a lot of ads, and it is actually continuously watching what post you're liking, what post do you spend most time on, which ones do you skip quickly. Basically what it does is that it keeps track of every click, so that it can actually show you more personalized content and more personalized ads. That's why you would have seen that you are looking into a product for some time, and then you see that those products are getting recommended to you. Those ads about those products are coming on more and more, right? So that clickstream data is actually a lot. So for each user, you are storing at what time that particular person would have clicked on a particular post or would have logged out, and all that data you need to store it in an external storage so here also we bring in an external storage, right? So next thing is that, okay, we have that data, right? But that data is a raw data. So you have the data of who is the user. It might be in the form of an Excel sheet, or it might be in the form of a CSV. And so what it is that the data is about who is the user, where did he click on, what time did he click on, was he logged in, was he logged out, and how much time did he spend on a particular post, at what time did he spend that much amount of time, all that stuff. But you have that data, but you have, let's say you want to go ahead and actually make sense out of that data, right? You want to perform some, let's say you want to perform some aggregations, you need to sort that data, and you want to find out some meaning out of that data. And that's where something called a Spark or Hadoop platform will come in. So don't get overwhelmed by this architecture. Since we are breaking it down, I suppose it would be easier to understand. So what that platform does is that it helps you analyze this data over several computers. So what it enables you is something called distributed computing. Okay, so it allows you to perform the analysis on the vast amount of data on different computers. And the processed and unprocessed data, now that you have the clickstream data too, that data is too huge and you need petabytes of storage for that. Okay, so that is where we bring in the data warehouse. Okay, data warehouse is also a type of a storage, but it's not, it cannot be accessed very quickly. And unlike your relational database or a NoSQL database, data warehouses cannot be accessed that quickly. So they have some kind of latency, but they can store a lot of data. Vast amount of clickstream data and the unprocessed or processed data are actually will be stored in the data warehouse, right? So next thing what we do is that, so since we are a full application, right? We have a business team, we have HR, we have the technical team and everything. So in a company like Facebook, in the end of the year, they might want to find out which kind of users are accessing Facebook more, what are their age, in which region do they come from, how a particular Facebook feature might be used, and how something might not be used. So recently, if you take the example of Twitter, in Twitter, there was something called Twitter status, right? So what Twitter status is, it was similar to Instagram status and Facebook status that we see. And there was something called Twitter status. But soon they found out that not many people are interested in these Twitter statuses. So they went ahead and actually removed that feature. So that's where this business intelligence and all your business analytics team, what they do is they extract and find meaning from the data that, okay, this feature is good, a lot of people are using this feature, whereas the other feature, or not many people are interested in that. All that they can figure out from the clickstream data that is coming in, right? The clickstream data that I spoke about. And one more interesting thing that you see is that the clickstream data is connected to the web server. Okay, so in the starting, I told you that how web server handles the UI component, it handles the user interface, it handles the HTTP requests, and it handles the HTML, CSS, and all that. right? So it is directly, that's why it is directly connected to the clickstream analysis, right? So here we saw that we have added that business intelligence part where the business people from your company can take out the data from the data warehouse and at the end of the year perform analysis, make bar plots, make charts, and yeah, basically make more sense out of the data. Right. So next thing we see is that a user, as we are the users, we can come in from the web browser, or we can also come in from the mobile applications. So let's say that you are a user, you come in from the browser, right? And you might post a video. Okay. But sometimes the other users coming from the mobile devices, they might not be able to access that video because that video is not in a format, because that video was posted from browser. It is not in a format that it can be viewed in a mobile device, right? So what I mean is that we need some kind of a video converter so that the browser, people coming from the browser can also watch those videos. People coming from the mobile devices can also watch those videos, right? So let's say the next thing is caching, or it is actually called content delivery network. So what this is that let's say you post a video on Facebook, right? You get a chance to interview Virat Kohli, and you post that video on Facebook, and that would definitely go viral, right? A lot of people, millions of cricket fans around the world, and people would like to watch that interview, what you guys spoke about. So what happens is that when the web browser or the mobile, it keeps on hitting the external storage, the same bottleneck situation arises, which I explained in this load balancer and in the DB cache, right? So what you're doing is a lot of people from a particular region are actually trying to access the video, right? So what this external storage or the web servers might not be able to successfully handle all the requests. So for some people it might load, for some people it might not load. We have seen that issue in AUMS also for all the second years and third years. We have seen that issue in AUMS where for some people it loads, for some people it does not load. Right. So when it comes to videos and streaming, you have something called content delivery network, which can actually, in AWS, what happens is that it will actually cache. By caching, I mean that the frequently accessed videos, the video which has gone viral, those things will be stored in an edge location. So this edge location, Shama actually talked about it a few slides ago. So so let's say you are requesting for the video from Hyderabad. Right. And a lot of people around the region are requesting for it. So if a lot of people are requesting for that, it will actually get stored near your location so that it could be easily handled and delivered to you. Right. So that is what a content delivery network is. So going ahead, next, you also see that Facebook and Instagram, all of them give you notifications, right? So you might see that a friend has posted a video, or someone has liked your post. So they give you notifications, and they also send you emails of several activities. Although you can go ahead and mark it as spam, or you can disable that video, but you have the option to, am I audible?
Yes,
Yes,
you're
sir.
audible.
Yes.
Yeah, because I got a notification that bad network quality. Right. I'm audible, right?
Yes, brother.
Yes.
Yes, sir.
Yeah. So where were we? We were in the notification. So you have seen that whenever one of your friends like a post or someone posts, you get a notification that your friend has posted a new video or updated his or her status, right? So that is where we need to bring in these services called SMS push notification and the email services. And and in a social media application, we also have the facility to chat with our friends, right? So the chatting is enabled by something called message queues. So queue is a data structure, and you will probably learn about data structures in your upcoming courses, the first years. So queue is a first in, first out data structure. So let's say the first message that you send has to get delivered first, right? So that service also we bring in here. So that so now we can see that the chat application is also, the chatting part is also integrated into our architecture. So now if you look at this, it is more than enough, right? So this is a bare minimum kind of a social media application. So this is not exactly Facebook. There are a lot of millions of services other additional to this that actually Facebook uses. But this is a bare minimum social media application. It also has a business end to it. It also has the data analytics part. built into it. So yeah, so you have everything that goes into a basic social media application. So now the final part about it is that, let's say you want to know how your services are working, right? You want that's where we bring in something called a monitoring dashboard. So what this monitoring dashboard is, what it does is that you can see you in the monitoring dashboard, you can see how your virtual machines are doing, how your web servers, your application servers are doing, how many how much database storage is left. All that stuff you can actually monitor from the monitoring dashboard. So yeah, that's all. This is the overall architecture of a basic social media application. So what now we will go ahead and do is that we'll go ahead and see, since we have some more time left, we can go ahead and convert this architecture step by step using AWS services, right? So this is basically fb.com on Facebook, on AWS. So we'll go ahead and convert to AWS architecture. Right. So the first thing that you remember I talked about was the virtual private cloud. It was a virtual network that you need. And in AWS, you have a service called virtual private cloud. Okay. So next thing that are getting replaced are these virtual machines, right? These virtual machines are nothing but computers. Okay. They are just computers that are inside the data centers. Okay. So these virtual machines, for these virtual machines, we have a service called EC2. And the disk that you see, the storage that you see, which is attached to them, that is called EBS, Elastic Block Storage, right? And these arrows that you see, do you remember how I gave the washing machine analogy and how I talked about how they scale, right? So when a lot of users are coming in, now we have 4 machines, they might expand to 10 machines. And when those users are not there, when the traffic is low, they expand down to two or 4 machines. A better example about that would be, let's say we have seen that in whenever Flipkart has those big billion day sales, right? A lot of people coming in, so they have to automatically scale their application so that for all those people, the content is loaded properly. So that's what this auto scaling does. And someone has to distribute all that load, right? Someone has to distribute all that load. And that's where you have the load balancer, which I talked about. For load balancer in AWS, you have a service called ELB, Elastic Load Balancer service. And also, I remember I talked about the DNS service, how your users don't need to remember the IP address. They can go ahead and just type fb.com and come to the website. Right. So that service is called Route 53 on AWS, and that is the DNS service available on AWS. Right. So going ahead, now we also talked about how when a lot of pictures are uploaded, we will actually need a external storage. Right. So that external storage is something called S3 bucket on your AWS. It's called a simple storage service. So so you can actually go ahead and store all those posts and videos into your S3 bucket, right? So you also so now going ahead, we talked about that content filter and how if some objectionable content is posted, you would actually remove that before storing it into the storage, right? So that for that also we have a service in AWS, and that is called recognition. Okay, so whenever something objectionable comes, it will automatically filter out, and which the things which are not filtered out go into the S3 buckets, into the external storage. Right. Now, moving on, I also talked about how if some people are coming, if you are posting a video from web browser and people want to access it from mobile devices, we might need to convert that video so that it is actually, you can actually see that in both the formats, right? So that's where something called a Lambda service comes up. Right. Now, don't get me wrong, Lambda is not actually a video converter. Okay, so Lambda is actually a serverless service of Amazon, where what you do is that you write a code. Okay, you write some code, you write the logic on how you can convert it, how you can convert a .mp4 file into a file which is supported in mobile devices, and you put that code in Lambda service. Right. So what happens is that Lambda is a event triggered service. What is an event triggered service? So whenever you post a video, it passes through the content filter and it falls into the external storage. Right. And that external storage, whenever a video is getting into the external storage, it will get automatically converted and put into the other S3 bucket, which deals with mobile devices. So this is where you have the Lambda event triggered function. The event is that something is getting uploaded into the S3 bucket, and the function is that it gets translated to the format which is supported by mobile devices. Right. So now we also saw about clickstream data, and I talked about how different how Facebook is recording whatever you are clicking on, whatever you post, what you watch. So for that also we have a service called Kinesis on AWS. These are all AWS specific services. So all other platforms like GCP or Salesforce also has Heroku, and all those all those other platforms also have all the core concepts are same, but the names might be different, right? These names are specific to AWS. So next thing, so Kinesis records the clickstream data. And next thing that we saw was how you have to analyze that data and make some meaning out of it, right? So that is where you have this EMR service. EMR is that Hadoop or Spark platform that I talked about. So what it does, it takes the Kinesis data, which is in the form of CSV or Excel sheet or raw data, and it makes meaning out of it, right? So there is also something called Glue. Glue is actually a ETL service. ETL stands for extract and load. I'm actually forgetting what T stands for. So I guess it's transform, but I'm not sure. So yeah, so what it does is that it actually gets the data from, okay, I think I forgot mentioning this, what is relational database and NoSQL database. So for that, we have services called RDS and DynamoDB. RDS is for relational database and DynamoDB is for NoSQL database. And the caching mechanism, the bottleneck, everything, the washing machine analogy that I explained, that here is taken care for the databases, that is taken care by the Elastic Cache, right? So now coming here, so I talked about this Glue service. So what it does is it also extracts the data from the DynamoDB and it gives it to the EMR service, which can then figure out and make sense of the data, right? So the next thing is the data warehouse, which I talked about. It is a vast database data warehouse. So it is called Redshift in AWS. So it can store petabytes amount of data. And next thing we discussed was how you need some business intelligent tools, right? So that your data analytics team can actually form charts and bar plots and figure out meaningful information from the data you have inside that vast amount of storage called Redshift. Right. So that is where these services called QuickSight and Athena come in. So QuickSight and Athena are business intelligent tools, and you can actually take a lot of inference from your data. QuickSight will help you plot bar charts and everything. So yeah, moving ahead, we also saw that we have something called the content delivery network. Yeah, so that is actually handled by CloudFront, the service called CloudFront. I told you how if a video goes viral, that is being cached and stored in an edge location so that people can easily access it. People don't have to wait. The loading buffering time reduces, right? So that service is being handled by CloudFront service from AWS. Okay, so now moving ahead to the final part, we have the SNS, simple notification service, and the SES, simple email service. So these are services which handle notifications that you see on your mobile and the emails that you get when you register into Facebook. So for the messaging queues, Amazon has something called Simple Queue service. So Simple Queue service also has an inbuilt FIFO data structure. That FIFO means first in, first out. That is queue, right? Basically a queue. So you would have seen when you stand in a queue, if you go into the queue first, you go out of the queue first, right? So that is what is called first in, first out. Then then finally, we might need to actually monitor how these EC2 machines are working, how much amount of storage does the RDS or the Dynamo databases have. So for that, we have something called CloudWatch. CloudWatch actually displays a lot of logs. By logs, I mean that you can actually see how the health of your architecture is, how the EC2 machines are performing, how much is left in your elastic block storage, or how much amount of data is being transferred from one service to other service. Everything you can actually monitor from the CloudWatch service. Right. You can also you also have something called the billing service. So, so our architecture now is complete. We have translated it. But just imagine that, okay, if you had to build all of this without AWS, without a cloud providing service, you'll have to set up your own servers. Then you'll have to hire maintenance people, management people, everything you'll have to hire, and it would cost a lot, right? But the advantage of AWS is that you can actually create this architecture in one click. There's something called, you can create an image of this architecture, and you can actually just with the one click, you can create the whole system itself, right? So this is basically, now we have basically built the fp.com, and going ahead, we also have a lot of other services, like there are some application services like API gateways. So you would have seen that when you have to integrate some other app into your application, so you would require a service called API gateway, and there are other networking services which make sure that your application is secure. Then you have something called then you also have DevOps services. So what do I mean by that is that when you write code, you can just push it directly into your application, so that once all the checks and code review is done, it will directly get deployed into your application. So if you know Git and GitHub, if you're familiar with Git and GitHub and continuous integration or deployment, maybe the first years are not, maybe second years and third years are familiar with it. So actually those services are GitHub and Git, all those services are also inbuilt in AWS themselves have those services, right? So yeah, I mean, I haven't gone into that because I guess this is enough for the basic overview. So I hope you all gain some knowledge and good points out of this. Thank you. That's all from my side.